The healer might come today. The healer might come and take. The healer might come and take away the pain. He might come and take it all away. The healer might bring the rain. The healer might
Hello. If you just got here, take about 2 minutes and work on this one real quick. These first two questions on this page. Alright, and then we'll start in roughly 3 minutes. Okay? Hello. We'll start with these two problems, okay? Just take about 2 minutes to do it. Spring break was good. Went by really fast though.
I know that we're still gonna die someday. But would you come and take it all?
I'm glad you like this song. Start in 1 minute. If you haven't already, take a chance to finish these two problems. Hello. All right. Good afternoon, people. Hopefully we get a chance to look at the first two questions. Who's Stormzy? Anybody know who this Stormzy guy is? No matter. Well, let's take a look at the first problem, which is, wow, okay. So if you look at this, what kind of pattern is this trying to follow? This is what is it doing? Plus 8 each time, right? Plus 8, plus 8, oh wow, crappy markers everywhere. So it's doing plus 8 each time. That means this is a arithmetic sequence. Remember arithmetic sequence formula? A1 plus n minus 1d, right? Like that. So So then, you can start with first term is 7, right? n minus 1d. So right now we're doing the nth term, which is the kth term, which is going to be the nth term, so it'll be m minus 1 times the difference, right? So the difference would be plus 8. So when you multiply it out, it'll be 7 plus, this is the formula, but you can do 8n minus 8 as well, and then it will end up being 8n minus 1, right? So that would be your nth term. Okay? So whatever this term is going to be 8n minus 1. Okay? And but what about this blank? If this is k, what would this be? How would I write that part? If this is k, what would this be? k plus 8, right? You're adding 8. k plus 8. Okay? So far so good? Alright. So the next part, it's similar, right? But instead it's geometric because you're multiplying by 2. Right, times 2 each time. Since you're doing that, then it would be, what, obviously 2 times k, right? 2k here. Because this is k, then this is 2 times k. Then similarly, we can do the geometric formula, which is g1 times r to the m minus 1, or ratio to the m minus 1, which is g1 is 1.5 times 2 to the m minus 1 power. Okay, so that would be your explicit formula. All right, so explicit, right? Explicit. This nth term we call this the explicit formula. Right, like this. Explicit. Why? Because it clearly defines your n in any given term. Okay. Now, however, there's also a different type of way to represent it. We call it the I forgot to put formula. The explicit formula. There's another way called recursive formula. Recursive means it's happening over and over again, okay? So when we're trying to represent something that's happening over and over again, like adding 8 or multiplying by 2 over and over again, we can use the next term in this term to define it. Okay, so we can find the next term based on the previous term, or this term. Does that make sense? Next term based on the previous term, or so for example, number 1, okay, we're talking about recursive form for number 1. Number 1, if you look at number 1, that's this one, right? 7, 15, 25. So what's the first one? First one would have to be 7, right? So first one is 7, so you'll put the first term. And I'll talk about why this is important in a bit. But first term is 7. Then the next term, right, Tn plus Tn can also be represented by the previous term, which is Tn minus 1 plus 8. Right, because you're adding 8 each time. What are we saying here? We're saying this term is equal to previous term, right? Because this is Tn minus 1, right? Plus 8. Like this, for example, T10, the 10th term is equal to T10 minus 1, which is T9 plus 8. Okay? Is that making sense? So that means whatever this term is, so let's just say T100, I know it's going to be equal to T99 plus 8. Okay? What is good about this kind of form is that it's very clear what the pattern is. You see the plus 8 here. It clearly shows that to get the next term, you just add 8 to this term. What is bad about this term is if the numbers is high, then it's hard to get to the actual term based on the first term. Why do we need the first term? Okay, let's look at two different sequences. Okay, let's just say 2, 5, 8, 11, right? Let's do number 1, 4, 7, 10, like this. Now, what would be the recursive part of this? Wouldn't it be Tn equals to Tn minus 1 plus 3? Right? Isn't that what it looks like? Right? What about the bottom one? How do I define the bottom pattern? If I put Tn, how would I represent it? Using recursive. So this term is based on the previous term, right? So it would be the same part with the recursive, right? But the difference, you see, they're completely different two sequences, right? One is 2, 5, 5, 8, 11, 1, 4, 7, 10. There's no single repeat term out here. So that's why you have to define the first term or some reference term, right? So the first one is T1 is 2, the second one is T1 is 1. Okay? That's the reason why you always need some sort of term to start with. You need to know some term. Okay, without knowing that term, you cannot fully define the sequence. Okay, very nice, Johanna. So the number 2 recursive obviously would be what? T1 is, the first term is going to be, I think it was 1.5. And Tn will have to be 2 times Tn minus 1. Okay, make sense? That is recursive. Okay. Any questions so far? Am I going too fast? Going too slow? So like we said, you must define T1 or T2 or any other term. Okay, you just need to define a term. Otherwise, you don't know which one you have. And I give an example here. Okay, look at these two. Same thing. Your recursive part will be +2 for both of them, right? And both of them, the recursive part looks the same. But the T1 is different, right? T1 here, first term is 1, first term is 2. Once again, these two needs to be simultaneously defined in order for you to have a full sequence. Make sense? So, let me give you some time for 4 and 5. And I want to take this time to take attendance. So if you're here, say here, so that I can mark you down. So It's Siley here. Can't find Siley. Well, Siley, if you're watching, send me an email or leave a comment. All right. Okay. Let's go over these two real quick. What's this? A T1 equals 1. And the recursive, what are you doing? You're adding 2, adding 3. What's going on? What are you doing here? What's going on here? What is the pattern? You're adding 2, adding 3, adding 4, adding 5, adding 6, right? So if you want to base your this term based on your previous term, then you have to add something, right? You have to add something. What are you adding here? So let's just say if it's adding n plus 1 every time. So I think you're almost correct. Because if you think about this, right? T2 right now, what's T2? T2 is 3, right? Which is 1 plus 2, right? So T2 is based on T1 plus 2 then, right? What about T3? T3 is 6, which is the same as 3 plus 3, right? Oh, hi, Siley. Got you. So T3 is 3 plus 3, right? But the number matches up with n. So it's not n plus 1. It's just n. Because we're basing this term off of previous term. Okay? So it's like, what is this? 6 is the third term is 3 plus 3, right? So it's the previous term plus 3, which is the number term. Okay, so it's going to be plus n instead. But you're close. I think you got the idea. How about this one? This is plus 2, plus 4, plus 6, plus 8, right? So this is going to be T1 is 1, obviously. But Tn is what? Tn minus 1. So 3 is equal to 1 plus 2. So you kind of want to see how it goes. You're multiplying by 2, right? So it has to be plus 2 times something, right? So what is this doing? What are you adding each time? You start from 2, and then 4, and then 6, and 8, but you're adding like a previous one, right? So like usually I want to put 2n here, but if you put 2n, it's not going to work because watch what happens if you put 2n. If you do 2n, it will be 2 like 2 so if it's T2, then it will be 1 plus 2, right? But this 2, if you put a 2 here, if you do n, it will be 4, right? Because it will be 2 times 2, which is 4. But that's not what you want. n minus 1 is correct. Okay, very nice. Why? Because you want to go 1 back, right? So you gotta test it out a little bit. Okay. Now, let's think about an alternative way to do this. Rather than having Tn equals that, sometimes we have another way of doing it is to do the next term. So Tn plus 1 is this term plus something. So this is like a different way of thinking about it. So the next term is this term plus, in this case, then you can put 2n, right? Because in this case, you're basing off your term as now. This is future. Okay? So if you're basing this on now, it will work because now your Tn is T1, right? T1, which n is 1, right? N is 1. Then the next term, T2, is T1 plus 2, right? And that will work. Okay? So there are two different type of recursive. Either of these will work. Okay? You don't have to do this. But if you define it as Tn, then you have to do this. If you do Tn plus 1, then you do this. Okay? Either way will be fine. How are we doing? So recursive, there are two parts, right? One is the reference point, which is T1 equals 1. The second part is the recursive part. The recursive part, as long as you get the pattern consistently right, then that's fine. Okay? The whole index just have to stay consistent with what you get. Okay? Need some further explanation, or we're okay with this? If you're okay, put 1. If you're not okay, put 2. Seems to be okay, I think. I haven't seen a 2 yet. Okay, so if you are okay with this, let's look at the next page. Let's look at some interesting problems. So this is the basics of recursive, right? So let's look at some of this. Okay, so let's look at number 6. Okay, look at number 6. So R of n represent number of regions, right, formed when n lines are drawn in a plane such that no 2 lines are parallel and no 3 lines are concurrent. Find the recursive formula for this. Find the explicit formula for this. Put 1 if you know exactly what this is asking for. Put 2 if you think you need further explanation. Trying to interact with you guys, you see. You can put 2. I mean, you don't have to put 1. Putting 1 doesn't make me feel necessarily better or worse. If you put 2, then at least I know that you're thinking about it. Put 1, that means things are too easy, right? Great. I see a 2. Good job. Okay, so let R, okay, two 2s, 3 2s. Okay, now everyone start putting 2. It's normal to put 2, okay, because this problem is very difficult to think about. The description is pretty interesting. So basically, it goes like this, okay? So you have a plane, right? In a plane, so every time, so let's just say R1, okay? Because they're doing R as the number of terms, right? So R1. R1, n is the number of lines drawn, okay? So if you're R1, then you can draw 1 line, right? If you draw 1 line on the plane, like this, How many regions does it break into? You draw a line here. Doesn't it break into 1 here, 2 here, right? So 2 regions split, right? So far so good? What about R2? That means you draw 2 lines. 1, 2. How many regions did it broke into? Isn't it 1, 2, 3, 4? 4 of them, right? So 4 is R2. What about R3? Well, once the line gets a lot, you have to kind of be careful about how you draw it. So they say they cannot intersect at one point, right? All 3 cannot be concurrent, right? So that means only 2 can intersect. So you can kind of get like this kind of situation, right? Because only 2 can intersect, and they're not parallel, so you don't have to worry about parallel lines. So they will intersect. So you will intersect at 3 points, and you get 1, 2, 3, 4, 5, 6, 7. 7 regions, right? Put 7. So far so good? That's what it means. Can you see a pattern in here? So the next one, R4, you draw 4 lines, right? So it's going to be 1, 2, 3, 4. But this one has to intersect, or this one has to intersect with that one as well. Because this is an infinite, right? So infinite point will intersect at some point. There's no boundary on this one. Okay, so you have 1, 2, 3, right? One more is 4. So I need to make sure that every single one of them intersect. Okay, like this. So I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. So, can you develop a pattern? Are we clear on why I have to make them intersect at some point? Because they will intersect at some point, right? This boundary is imaginary. There's no boundary in planes, okay? So you will have to cut somewhere. So you got to make sure every single 2 points, 2 lines will intersect in your drawing. Okay, that way it will work. Okay? All right. So what is the recursive formula for this? Let's look at the pattern first. Okay, so the pattern goes like this, right? 2, 4, 7, 11. Okay. By the way, speak of 7-Eleven. Do you guys miss 7-Eleven? The days that you guys walk to 7-Eleven from campus. %1,000% yes. Man. And Starbucks. Man. Seriously? Drive to 7-Eleven? Okay. Alright, so let's look to see the pattern, right? So you got what? 1, 2, 3, 4, and you get what? 2, 4, 7, 11, right? So pattern is what? It's a pattern we've seen before, which is a +2, +3, +4, right? So with this pattern, I can then form R1 is obviously 2, right? So this is recursive. Okay. R1 is 2. Rn is equal to Rn minus 1. We're adding, right? So we're adding something. But we're adding... What are we adding? We're adding... Each time this number will be the same as the term number. You see that? The term number? 2, 2, 3, 3, 4, 4. So it's plus n. Okay? So that will be your recursive formula. What about explicit? Remember how we did the explicit for this? We kind of have to figure out what this is equal to something times something, right? Something times something. Or we can go back to our 1, 3, 6, 10 pattern that we had and do it from there. Either way, it would work. But here I'll just use, so 2 is, so I'm going to use this. Okay, so this is 2. So 1 times 2, right? 2 times 2, 3 times, oh, that fails. No good. Can't do it like that. So I guess I will use the one that we did before, which is, remember this term, 1, 3, 6, 10? This particular sequence we've done before. Why is this good? Because we know the answer to this. If you forget, you can flip it back. 2, 3, 4, okay? So this one is the same pattern as the previous one, right? 2, 3, 4, 5. If you compare this to our current form, which is 2, 4, 7, 11, right? So this is the same exact pattern, right? Except the starting point is different. So it's basically this plus 1. So this one we have done before, which is n plus 1 over 2. I think this one. Flip it back if you forget about this one. And then since we want to do that one, we just add 1 to every term. Okay, and that will work. Okay. All right. So that's explicit. This is from the 2 weeks ago, right? All right, last one. So each day, 8% of quantity of radioactive iodine will decay. Use a recursive formula to show this. Okay. So what does that mean? So number 8. So Q. Let's just say quantity. Okay. So let's do Q. Qn is equal to something, right? So the radioactive will be 0. So it's 8% decay, right? 8% decay means how much is left. That's 0.92. Why is that? Because 1 minus 0.08. Right? Think about it like that. Okay. This times the previous day. Is there a way to find what Q1 is? Did they say? Did they tell us? Is there information provided to say what the initial amount is? Or does it matter here? There's no mass, but we can assume 100%. So it just basically, it didn't say, so we don't have to put anything for Q1. Okay, whatever Q1 is, you're decaying by 0.92 after first day. Okay, first day? Yeah, first day. All right, so remember what half-life means? Half-life. Remember we talked about half-life before? What is half-life? What is half-life? Half-life is the amount of time, okay, to be half. Okay, basically, you know, if you think about what your half-life is, like my half-life, I don't know where it is. It could be more or less than my current life, right? So if you think about it, it's exactly half of what the total amount of your life span, basically. So the full life would be going to zero, right? Like you're decaying to zero. Half-life is the amount of time to be decayed to half. Okay? So basically, to calculate this, you start with half of Q1, right? That's your goal. Yeah? Half of Q1 is 0.92, okay, times Q1. How many times? N minus 1 times. Let me deal with this. Basically, because it doesn't matter what you start with, the Q1 will go away. Okay, Q1 will go away. Okay? So you're solving for this. Wait a second. Q1, Q2, Q3. Yeah. Sorry. You don't yeah. Initial amount, if it's 10, then you're doing oh, I know why. Here. Let's fix this a little bit. So instead of Q1, we're going to do Q0 instead, because Q1 is after the first day. All right, so we're going to fix this a little bit. So instead of n minus 1, we'll just do n, because this is before everything has happened. Because Q1 here, n, this is n amount, right? So you don't want it n to be first day. You want n to be before everything has started, okay? So don't do this part, just do n. So anyway, Q0 has canceled, so half is equal to 0.92 to the n power. How do I solve this? Remember how to solve an exponent? How do I solve for exponent? How do I solve for exponent? What is exponent? How do I solve for it? This is something that we talked about before. This is a topic everyone loved. Log! Thank you. So you can do log both sides. Okay, I'll just do natural log. 1/2 equals natural log 0.92 to the n. Why is this good? Because you can pull the n down, right? So you get natural log 1/2 equals n, natural log 0.92, then divide it over, right? So you can use your calculator here. So n equals natural log natural log half divided by natural log 0.92, which is approximately 8.5 days, right? 8.5 days. That means in 8.5 days, I will be approximately half of what I have. No matter how much I have, how much iodine I have, I will be half in 8.5 days. Okay? Importance is that the amount doesn't matter, it's the ratio that matters. Okay? If I have 10,000 pounds of iodine, I will still get half of that. I'll get 5,000 pounds of iodine in 8.5 days. Okay? If I have 10,000, 10 million, then I'll get 5 million in 8.5 days. Okay? So that's the power of exponential decay. All right. Housekeeping. So, housekeeping items. Housekeeping items. So, as you know, first of all, check my email. Check email about credit, no credit. Okay, I sent an email earlier this morning about how the grade goes. Number 2, so it has to do with homework for the day, for this week actually. So first of all, this is the more important timely thing. Finish formative assessment on Pearson. Okay, please do this by tomorrow, I think. By tomorrow. You have to wait. By tomorrow? Let me check. Is it by tonight? Let me see. For you guys, it is due formative assessment. Oh, it's due today. By tonight. Okay, by tonight. So this is really simple assignment. There's only 3 questions. Okay, 3 questions. Should take you about 5 minutes. Okay, 3 questions. So that's the first part. Make sure you submit by tonight. Number 2, that's Google Classroom. There are 2 worksheets. Okay, it's already there. About how it's graded, it's also in the email, but it's based on completion for formative assessment. Okay. So if you are reading about the email right now, basically, so we are going to have a chapter test at the end of all this, okay? But it's not gonna be like, it's going to be like a simple low task chapter test compared to how it was. Obviously we've changed to credit, no credit, so as long as you don't fail, then you don't fail, right? Pretty straightforward. Just because you had an A before, well, the common message among all district is that even though you have a high grade, then you can't necessarily pass by not doing anything for the rest of the school year or whatever. But obviously it's to a scale, right? So like, if you didn't expect to fail, you probably won't fail. Okay? So continue to do your work, continue to do your work, continue to do your work, continue to show up your class. I mean, what else are you gonna do not showing up to class, right? This is the last chapter, so this is going to be the only test that we'll have. So, most likely, I would say so. We have to decide whether or not we are giving. Did we test for chapter 8? Let me see. I don't remember testing for chapter 8. Did we test for chapter 8? I don't think so. Let me see. Okay. Most likely, this is going to be the only test we'll have, and so chapter 12, right? This will be the only test we'll have, most likely, okay? At a glance, there's no F in the classroom, so if you keep up your work, you will pass, okay? Just don't slack, and you should pass. The requirements for passing is also stated in the email, so if you're having problems, let me know. But most likely, if you are keeping up the work, you should be fine, okay? Any other questions? So these are the assignments for the week. First of all, please go finish the 3 problems, probably right after class end or maybe right now. And number 2 is there are 2 worksheets on Google Classroom that's on the assignment under recursive sequence. So do those 2 and turn it in before, I think, for you guys is Sunday night, I think. I don't know about final schedule yet because the final schedule hasn't been out yet, so we'll decide what the final schedule is going to look like probably soon, okay? Once again, final is not going to be too high stake either, so even if we have a final, it shouldn't affect your grade that much. Like, it shouldn't be like, oh, you know, I am having a passing grade and then I failed my final and then all of a sudden I'm not getting credit for this class, okay? I'm trying to avoid that kind of situation, but obviously you're trying to try the best as you can, keep up the work, okay? So yeah, the homework, so this part is the formative assessment is due tonight, but the 2 worksheets due Sunday night, okay? Sunday night. I think it also says on the Google Classroom. Okay. Any other questions? So I wouldn't worry too much about grading if you're already passing. Just keep up the work. Do what you usually do. Don't check out. Then you'll be fine. Okay? Is that clear? I'm trying to keep it simple, you know? So formative assessment is something that I want to keep up because I want to see how much you get. So it's based on completion, so just try your best. If you don't get it, you don't get it, right? So no need to over forcing it. I think formative assessment, I put it as like a 3 try type of thing. So if you can't get it right in 3 tries, you probably don't get it. I'll probably go over it. Okay? Any other questions before we go? All right. Well, have a great day then. Yeah? I'll stay for an extra like 2 minutes just in case you have more questions. Goodbye. No problem. Goodbye. This music, man. Goodbye. No problem.